Hello, in this video, we're going to look at the Nobel Prize in Physics from the year 1904, given to Sir William Ramsay for his discovery of the inert gaseous element in the air and his determination of their place in the periodic system. First, we're going to look at his work. The air around us consists of several different gases, mostly nitrogen gas and oxygen. Through weight comparisons between air and nitrogen gas formed in chemical processes, William Ramsay, along with Lord Rayleigh, showed in 1894 that air also contains an element unknown up till then, which was given the name argon. It does not react with other elements, but is a noble gas. After discovering another noble gas, helium, Ramsay predicted other noble gases based on a periodic table of elements and could establish the existence of neon, krypton, and xenon. This is from the work section of the official Nobel Prize site for 1904. Uh, you can go to it by following this link. Here you see the Nobel Prize diploma the laureate received. Beautiful as always. Then some biographical information which is relevant to the work. Ramsay's earliest work in the field of chemistry, besides his doctor's dissertation about the period he published work on picoline and in conjunction with Dobie on the decomposition products of the quinine alkaloids. From the commencement of the 80s, he was chiefly active in physical chemistry. Then a new subject, a new field. His many contributions to this branch of chemistry being mostly on stoichiometry and thermodynamics. To these must be added is the investigation carried on with Sidney Young on evaporation and dissociation in 1886 to 9 and his work on solution of metals in the same year. It was, however, in inorganic chemistry that most of his celebrated discoveries were made. As early as 1885 to 1819, he published several notable papers on oxides of nitrogen and followed these up with the discovery of argon, helium, neon, krypton, and xenon. Led to the conclusion by different paths, and at first working together with both Lord William Ray Ramsay, succeeded in proving that there must exist a previous unknown gas in the atmosphere. They separately worked in their separate laboratories on this problem, but communicated the results of their labors almost daily. At a meeting of the British Association in August 1894, they announced the discovery of argon. While seeking sources of argon in the mineral kingdom, Ramsay discovered helium in 1895, guided by theoretical considerations founded on Mendeleev's periodic system. He then methodically sought the missing links in the new group of elements, and he found neon, krypton, and xenon in 1898. Yet another discovery of Ramsay, in conjunction with Soddy, the importance of which was impossible to foresee, was the detection of helium in emanations of radium. This is from the biographical part of the official Nobel Prize site on this Nobel Prize of 1994. 1994, yeah. You see the spectrums of the different gases Ramsay discovered. Where you can see it from left to right: helium, neon, argon, krypton. Then from the award ceremony speech by Professor J. Cederblom, also summarized from the official Nobel Prize site. One of the most prominent features of natural science research in our day is the reciprocal action characterizing physics and chemistry. Causing an important discovery in one of these sciences must always invariably to affect the sister science. Thus, Lord Rayleigh's investigations concerning the physical properties of certain gases that had just received awards give rise to a whole series of surprising and important discoveries in the department of pure chemistry. Lord Rayleigh, having proved the remarkable difference in density existing between atmospheric nitrogen and chemically prepared nitrogen, Another British scientist, already well known as an eminent chemist, received permission to cooperate in the continued investigations with the intention of discovering, if possible, the cause of the peculiar state of things previously mentioned, the density dismant. This result of the cooperation was the discovery published in 1894 that air contains a gaseous component previously unknown of nearly 1.5 the density of nitrogen, which explains the higher specific weight of the atmospheric nitrogen. A careful study of the properties of the new gas soon proved, beyond all doubt, that the new chemical element had been discovered, which, owing to its disinclination to enter into chemical association with other elements, was called argon, the inactive one. It's a noble gas. Not content with having proved the presence of argon in the gaseous envelope of the globe, Lord Rayleigh, chemical cooperator on his own initiative, devoted himself to searching for the occurrence of argon in the solid crust of the Earth. This led him to a new discovery, scarcely less surprising than the preceding. He succeeded in isolating from certain uranium mineral a gas which was in the spectroscope proved identical not to argon, but to the long-sought solar element helium, hitherto undiscovered on Earth, the existence of which had been demonstrated by Janssen, the French astronomer, during a spectrographic examination of the solar chromosphere in 1868, while making observations on the eclipse of the sun in India. It has subsequently been found that helium is also present in water of some mineral springs, in certain meteorites, and that, like argon, only in a far less degree, it forms a component of the atmosphere of the Earth. As soon as the atomic weight of the new gases had been approximately determined as 4 for helium and 40 for argon, the energetic scientist was led by theoretical reasoning to search yet for another elementary gas, the atomic weight of which would lie between the two preceding gases and would probably be about 20. Having made a great number of fruitless attempts in various directions, he at last obtained an active agent when the problem of making liquid air on a large scale was practically solved. With the assistance of the low temperature, which occurs when liquid evaporates at minus 200 degrees Celsius and lower, he was able to obtain considerable quantities of liquid argon without any great difficulty, and both by fractional distillation thereof and by directly fractionation of liquid air, he succeeded in demonstrating in the more freely volatile fractions the sought-for element, which then was called by him neon, the new one. Not was this all. In the less freely diffused fractions of the air, he almost simultaneously discovered the two new elements, both gaseous at ordinary temperature, of greater density than argon, the existence of which he had predicted, though with a rather less certainty, and for which he proposed the denominations krypton, the inner one, and xenon, the strange one. These gases occur in the air, but sparingly as a rule, for while argon forms nearly 1/100th of the volume of the air, neon occurs only as 1 to 200,000, helium as 1 to millionth, krypton as 1 to millionth, and xenon as about 1 to 20 millionth part per volume. This, more than anything else, will enable us to form an idea of the vast difficulties which attend to these investigations. In spite of all these obstacles, however, it has not only been possible to isolate the new elements, but also to study the peculiarities with accuracy which enabled their place to be determined in the periodic system of elements. It has been demonstrated that the 5 new gases, or noble gases as they are often called, form a natural family of elements which, by the absence of electropolarity, is strictly differentiated from all the elements previously known, filling a void in the periodic system, hitherto existing between the highly negative halogens and the highly positive alkali metals. The discovery of an entirely new group of elements, of which no single representative had been known, with any certainty is something utterly unique in the history of chemistry, being intrinsically an advance in science of peculiar significance. The more remarkable is this advance when we recollect that all these elements are components of the atmosphere of Earth, and not through apparently so excessive for scientific research, yet for so long a time baffled the acumen of the eminent scientists who from the time of Scheele, Priestley and Lavoisier to our own day have been occupied in determining the chemical and physical properties of the air. The discovery, however, signifies far more than the simple addition of 5 new elements to the 70 that are already known. This to no slight degree owing to the innate character of the new gases, which certainly renders their study very difficult, but at the same time places them in a very peculiar position among the other elements. In spite of repeated and indefatigable endeavors, it has been found impossible in any authenticated case to induce chemical combination either with each other with the other known elements. Such a total inertness among elements was previously unknown. Indeed, it was almost generally believed that the power of entering into chemical reaction was a fundamental appurtenance which, though in a higher or lower degree, characterized all the elements. The discovery of the new noble gases has removed this impediment to our knowledge, widening our far too narrow view of the nature of these elements, and for this reason, from a theoretical aspect, it is of special interest. This interest has of late still been further heightened by the observations that the spectral lines of helium appear in the emanations from radium, that's a very puzzling element, an observation which has bear fruit in the results of science. The full extent is not now impossible to foresee. Okay, this is a summary of the award ceremony speech from 1904 for the Nobel Prize Chemistry. If you want to complete complete speech, follow this link. And here you see the spectrum taken from helium and neon. The same for argon above and krypton. And finally for xenon and radon. Well, this has been the first two-part series about the Nobel Prize of Chemistry 1904. Next week, a video will be posted on the Nobel Prize speech by Sir William Ramsay on the same subject. Thank you for watching.